Hello again. Recently, I started working on a new project and wanted to combine a set of tools and technologies that I believe will work seamlessly together. Here's what I had in mind. First, I wanted to adopt test-driven development as it would serve as a guide for my design, help me stay focused on my tasks, and ensure the system behavior was safe to refactor. Second, TypeScript offers excellent tooling support, optional contracts to enforce design decisions while coding, and useful language features such as strict null checking. Finally, I plan to utilize ECMAScript modules, also known as ES modules. These modules would allow me to run my code using popular engines like Node.js or Deno. Alternatively, I could execute my module and all its dependencies directly within a browser environment. However, setting up this combination of tools and technologies turned out to be more challenging than expected. To assist others facing a similar situation, I decided to share both the final outcome of my work and the step-by-step process of achieving it using test-driven development. If you're eager to start writing tests using TypeScript and ECMAScript modules right away, I've included a link to the template repository I created below. On the other hand, if you're interested in understanding how to tackle a problem like this using TDD, I encourage you to continue watching. In test.ts, we have a simple test written using TypeScript and ES modules. Let's go through each line to understand our expectations and how this test ensures that a repository meets them. The first line imports an assertion library. Specifically, we are utilizing a library called assert. This NPM module aims to mimic the functionality of the Node.js assert API while being compatible with browser environments. It's also important to note that we're using the ES module default import syntax, which we will explore in more detail later. Moving on, the subsequent line deals with importing the code under test. We employ an ES module named import to load this file. Next, we encounter a describe block, which is utilized in behavior-driven development, or BDD. BDD is one of the various testing interfaces available for writing tests. Describe is used to mark out an important component of a system, in our case it's the generate truth function, and any specifications that follow are assumed to be under the context of the component we have described. Following the describe block, we encounter the it block. The it block is used to specify an expectation. In our test, we are stating that we expect the generate truth function to return true. It's worth mentioning that BDD interfaces promote readable tests, and the test we've defined here can be read as generate truth should return true by combining the titles of the describe and it blocks. BDD test reporters often present test names in this manner to enhance comprehension. Finally, we utilize the assertion library to ensure the return value from the generate truth function is true. To get started, all we need is our test and an expectation that running the command npm test will eventually lead to a passing test. I have skipped a few steps by assuming the installation of Node.js and npm, so if you haven't already installed them, please visit the links below. Before we begin, it's worth taking a moment to talk about test-driven development as a process. With TDD, we start with just a test and an expectation that, when running our tests with our tool of choice, the test will eventually pass. From this point onwards, all of our work will involve taking small steps guided by feedback we get from the computer, progressively moving closer to our goal. A wonderful quote that encapsulates the TDD process came from an engineering YouTube channel called Stuff Made Here. After many attempts to resolve a bug in one of his machines and finally fixing it, the host mentioned that he ran out of ways to do it wrong. To me, this beautifully summarizes the ethos of test-driven development and perhaps engineering as a whole. Now, let's get back to our project. Running npm test produces the following result. Based on the error message, it is evident that there is no package.json file available for npm to inspect and understand how we intend to execute our tests. Therefore, let's add a package.json file to address this issue. After adding a blank package.json file and running npm test, we encounter a new error. The error message informs us that Node expects the package.json file to contain valid JSON data, and an empty file does not meet this requirement. By adding an empty JSON object to package.json, we have enough structure to run npm test. Now npm is telling us that we are trying to run this test script which has not been defined. Let's define it. After adding a scripts property to package.json and opting to use Mocha, a popular and simple JavaScript testing library for our project, we proceed to run npm test. The script now runs, but npm tells us it cannot find the Mocha executable. We need to install it as a development dependency, which we will do now. By adding Mocha to the dev dependencies property in our package.json file, we ensure that it is available for use in our project. However, we still need to install Mocha and its dependencies on our local machine by running npm install. Once the installation is complete, we are now ready to run our tests again. However, when we run Mocha, it doesn't find any tests to run. By default, Mocha is not aware of TypeScript files. To address this issue, we need to instruct Mocha to explicitly include our TypeScript test file. After adding test.ts as the spec argument to the Mocha CLI in our test script, we can run Mocha again from our test script. Mocha now reads the file, but Node.js doesn't know how to process it when Mocha attempts to load it. There's a file named getFormat that we will review later, but for now it's safe to assume we need to give Node.js some help to get started with TypeScript. To use TypeScript in our project, we will add a new dependency named tsNode. tsNode is a just-in-time TypeScript to JavaScript transpiler. It allows us to pass TypeScript files to tools like Mocha, which expect JavaScript, and tsNode will convert those files to their JavaScript equivalent before Mocha processes them. By hooking into Node's require lifecycle, tsNode ensures that whenever a TypeScript file is requested, a functionally equivalent JavaScript file is returned. After adding tsNode, we run our test and encounter several errors related to TypeScript compilation. We can take a look at the first error briefly to discuss the error format. The error format consists of a description line, followed by the context in the affected file where the error occurs. The last two errors indicate the describe and it functions cannot be found. And, while we won't use it for now, the stack trace is presented after the error list, which can guide us towards the source of errors if we need further context. Upon reviewing the errors, we notice the first error is related to the generate_truth file not being found. Recalling our understanding of how tsNode works, we can infer that the JavaScript extension is expected due to the transpiled test code trying to import it. To resolve this module error, let's add a TypeScript version of the file so that it can be transpiled correctly and imported as expected. After adding an empty generate_truth.ts file, we can see the module is found and loaded successfully, but it does not export the expected generate_truth member. To fix this issue, we need to export the generate_truth member from the generate_truth.ts file. Exporting an undefined member from generate_truth is another step forward, but it leads to a new error during testing. The error indicates that TypeScript cannot invoke something that may be undefined, which is the case in our situation. To resolve this error, we need to add a proper definition and implementation to our exported generate_truth member in the generate_truth.ts file. Exporting the function from the generate_truth.ts file allows us to make progress in our testing. However, we are now confronted with missing name errors, indicating that Node.js cannot load these Mocha variables correctly. Node suggests adding the types Mocha package to resolve the issue. Let's proceed with installing the types Mocha package and see if that helps address our error. Despite installing the types Mocha package, the same error persists when running the tests. To understand what might be causing the issue, let's examine the stack trace. The stack trace reveals that tsNode is running, which is a positive sign. However, there's a noteworthy detail. Node.js is attempting to load common JS modules instead of ES modules. The behavior occurs because Node.js defaults to common.js unless instructed otherwise. To resolve this, we need to configure Node.js to use ES modules. Let's take the necessary steps to update our configuration and ensure Node.js uses the correct module loading behavior. After setting the type property in the package.json file to module to enable native ES modules in Node.js, we encounter a familiar error where Node.js is unable to load TypeScript files. Upon closer inspection of the stack trace, we notice that Node.js is indeed attempting to use ES modules, which is a positive development. However, the error points to the getFormat file again, suggesting that there may be an issue with how Node.js is handling TypeScript files. Let's investigate the problem further to understand why Node.js is not loading TypeScript files as expected, specifically in the context of the getFormat file. Looking at the getFileProtocol module format function in the getFormat.js file, we can identify a few important behaviors. For JavaScript files, Node.js inspects the package to determine if it has opted in to be an ES module. Otherwise, it assumes it is a common JS module. When dealing with other file formats, Node.js looks for the extension in a format map. However, it seems that tsnode is no longer registered as a handler for TypeScript files, causing our troubles. There's a block of code related to extensionless files, but it's not currently relevant to our situation. The issue is surfaced in the fact that the get file protocol module format throws an error if it cannot find the required extension in the format registry. After some research into how tsnode functions, there are in fact two ways to register it with Node, depending on which module system you intend to support. Our current approach only works with CommonJS modules, and changing our package to an ES module prevents tsnode from loading at all. Let's see if we can fix this problem by instructing Mocha to use the correct registration with Node for ES module packages like ours. Mocha allows us to provide runtime parameters to Node via a mocha.rc.json file. Specifically, we can tell Node to use its experimental ES module support with the tsnode ES module loader. Removing the tsnode CommonJS hook from our test script and running Mocha again confirms that Node's custom ESM loader is functioning as expected. We see the loader is running as Node provides a warning message indicating that we are using the experimental feature. However, despite this progress, there's still a missing piece of the puzzle. The stack trace shows us that tsnode is using the same files, but it's now loading them using ESM. Node.js itself is also loading them from ESM. So what could be the missing element that is preventing us from achieving our goal? Let's dive deeper into our Node.js configuration and investigate what could be the final piece we need to complete our journey. Upon examining the tsnode configuration, we gain insights into how it compiles our code. Three properties stand out as particularly useful. The module property determines how imports and exports are handled in the transpiled code. ES module interop acts as a workaround for certain TypeScript compatibility assumptions, and module resolution determines how tsnode will itself load modules before transpilation. The issue lies in the module resolution property, which is set to node 10, an alias for CommonJS. This means that tsnode attempts to resolve modules in the CommonJS format, which is not our intention. To address this, we can override tsnode using a tsconfig file. While typically used for TypeScript configuration, tsconfig.json can also be utilized for tsnode. We can set the module resolution property of tsnode's configuration to node 16, an alias, again, for ES module support. This tells tsnode to use Node's native ES module loader when loading modules before it compiles our code. However, our configuration isn't complete yet. Upon reviewing the tsnode configuration again, we notice that the module option is mistakenly set to CommonJS. To rectify this, we can add an override to set the module property to ES6, the version of ECMAScript that introduces modules. With the updated configuration, we finally have the module and module resolution properties correctly set. Executing our test once more, we observe that the describe and it functions are loaded correctly. However, we encounter an error with our assert library and some issues with file extensions, which can be addressed in subsequent steps. Let's go in order and fix our import syntax for the assert import. To address the error with the assert library, we have multiple options, including revisiting the ES module interop setting that was mysteriously removed from our tsnode configuration. However, a simpler option is to simply switch our default import into a namespace import. By using a namespace import, we can gather all the exports from a module and assign them to an object of our choice. This approach should suffice for our needs. Upon running the test again, we encounter one final compatibility issue that requires our attention. Let's briefly review how TypeScript handles ES module imports so that we can fix the issue in the next pass. To summarize the linked article, TypeScript, Node, and tsnode handle ES module imports in a way that requires file extensions and leaves the import statements untouched by the compiler. To ensure that TypeScript import statements work correctly in their transpiled JavaScript target files, it's necessary to add a JS extension to the TypeScript imports. If you're interested in more details, you can refer to the article linked below. Additionally, if you prefer automation, there are tools available that can assist you in automatically adding the required file extensions to your import statements. With the addition of the JS extension to the imports, running the test finally gives us a failure. The failed assertion indicates that undefined indeed does not equal true. At this point, it may be tempting to doubt the logic of such a simple statement. However, we are on the brink of success, and it's almost time for the test to pass. Let's proceed to resolving the final issue of an improper return type. By returning true from the generateTruth function, the test finally passes. After all the TDD discipline and effort, we have successfully achieved our goals. We have TypeScript and ES modules working in symphony that serenades us atop the TDD mountain. Congratulations on reaching the summit of your testing journey. Cheers to your success. Now that we have our passing test, we can put the finishing touches on our repository with a few refactoring tasks. We will add the spec property to our mocha.rc.json file and remove it from our test script. This ensures that Mocha configuration is unified. To avoid a known bug in Node 20, we will specify the node version in the package.json file to be 18. If you'd like to know more, check the link below. We will add the ESM flag to tsconfig.json. This ensures TS node will use ES modules whenever it is loaded. We'll also add a Mocha bootstrap.ts file to test running Mocha without using the Mocha CLI. This allows us to use TS node directly and omit the compiled JavaScript code if we are unsure if the compilation process is creating an issue. And we'll also explicitly import Mocha's describe and int globals in our tests to ensure they are working correctly without relying on any globally injected state from the CLI. This will help us if we want to test the compatibility in the browser. With these final adjustments, we can confidently complete our TDD journey and ensure that our repository is in a robust and reliable state. Thank you for joining on this journey to set up TypeScript testing with ES modules. Hopefully this presentation has provided you with valuable insights and guidance for your own projects. To further explore and apply what you've learned, it's encouraged that you clone the linked template repository. This template offers a minimal, test-driven setup that utilizes ES modules, making it compatible with engines like Node.js and Deno, as well as modern browsers. With this template, you can continue building and testing your TypeScript code with confidence. Your time is appreciated, as well as your interest in this topic. If you have any further questions or need additional assistance, please don't hesitate to reach out. Happy testing and happy coding. Thanks.